Hello, dear students. This is Vijay Lakshmi. Welcome to WinMaths YouTube channel. Here, this session, we will discuss the concept application of derivatives for second PUC. Here, this YouTube channel helping students across Karnataka to excel in their PUC board exam and competitive exam. Here, mainly the concept of derivatives. Okay, that is, we already learned about the how to find the derivatives of the functions, that is trigonometric functions, composition functions, implicit function, exponential function, as well as logarithmic function. And also we have learned the second order differentiation. Okay, here in this chapter we have to use the derivatives. Okay, wherever we have to use the derivatives, we have to study here. Okay, the derivatives, or we will study the application of derivatives in various disciplines. For example, in engineering, science, social science, and many other fields. Sometimes, for instance, we will learn how to derivative can be used. Here, the change of quantities. We have to use the derivatives for determining the rate of change of qualities, then find the equation of tangent and normal, and also for finding the turning points on the graph of the function, which is turn will help us to locate points at which largest or smallest value. Okay, here we have more useful of there is a application of derivatives. Then the first one concept of application here, that is rate of change of quantities. Here we already know that ds by dt. Okay, here ds by dt denotes, okay, this ds by dt denotes the rate of change of quantity. Okay, that is the derivative of ds by dt means the formula denotes of derivatives, the change of distance with respect to the time. Okay, here ds by dt represents the change of distance with respect to t. We already know that the formula. This diagram indicates the formula, that is here distance, speed, time. We want distance, so I can want distance, so calculate speed into, okay, if we have speed, by using this diagram I can say distance by time. Similar to that of we want time, and that time distance divided by speed. Okay, so I simply denoted the formulas related to distance, speed, time. I can take dst. Okay, in similar fashion, whenever one quantity y varies with another quantity y, satisfying the sum rule, that is here the given function of the form y is equals to f of x, then it may varies with respect to x, then we have dy by dx, or sometimes we can replace or represent f dash of x here. F dash of x means the rate of change of y with respect to x. This represent the dy by dx represent the rate of change of y with respect to x. Okay, here x we want, or we substitute the value x is equals to x naught. So that is f dash of x naught represent the rate of change of y with respect to x at x is equals to x. Okay, based on this concept we will discuss the problems. Okay, here first one example, this is very important for 1 marks MCQ. Okay, most of the time it will be asked for multiple choice question. First, find the rate of change of area. First, have to read the question completely and understand the concept neatly. Here, find what is that rate of change of area of circle per second with respect to radius. Okay, here they given area. Okay, we have to find the rate of change of area with respect to the radius. We already know that given point. Okay, given radius only, that is 5 centimeter. Other than we don't know. But here we have to find the area. Okay, here area of circle. So I can take, let we know that what we know, that is area of circle. Okay, area of circle 5r square. Here it will be changes. Area of circle will be changes. That only we have to calculate with respect to r. Okay, therefore we have to find area. What is the area? I can denote area by A, dA by with respect to radius only. Okay, dA by dr at when r is equals to 5 centimeter. We have to calculate this one. Okay, first I can consider the area. That is area is equals to pi r square. Differentiate with respect to radius. That is with respect to r only, because here we take area is equals to pi r square. Here the square of radius. So I can differentiate with respect to r. So dA by dr is equals to pi becomes constant. Again taking d by dr of r square. Now dA by dr is equals to by constant differentiation of r square with respect to r, that is 2. Okay, it becomes 2 pi r. We want change of area, rate of change of area when r is equals to 5 centimeter. So I can take dA by dr at r is equals to 5. So what is the dA by dr? 2 pi r. In place of r, I can take 5. 2 into 5 into r. It becomes, what is the r? 5. Okay. 2 into 5, 10. 10 pi with respect to per second. Okay. Rate of change of area. What is the formula for area? That is here area square, that is centimeter square. Okay. This is the result. Now I am going to take the example number 2. Okay. Let's consider the example number 2. The volume of cube is increasing at a rate of 9 cubic centimeter per second. How much fast is the surface area increasing when the length of edge is 10 centimeter? Here we have to find the surface area. Okay. What is the surface area of cube? What is the surface area of cube? We know that cube means all sides are equal. Here, this is the cube. Okay. Here in this concept, diagrams are very, very important. Okay. I can take diagram and I will explain the concept here. So, the surface area means all the surrounding. It will be increasing. Okay. Here, cube means all the lengths. Okay. Here, length of this side A equal. Okay. Length of this side equal. Then upper length is also equal. Here the length is A. Okay. Here the cube has 6 faces. Here the front face, side 2, backward 1, upper and lower. So what is the surface area? First let us consider the given points. Okay. We want find the rate of surface area. Okay. We have to find the Fast is the surface area increasing when length of edge is 10 centimeter. So I can take, let S be a surface area. Let S be a surface area. Okay. Then what do you mean by the surface area? Formula. There are six face, that is 6a square. The surface area of volume of cube is 6a square. Then again I can take the given point. The volume of cube increasing at a rate of, here volume, okay, volume will be increasing. Then I can consider V be a value. I can consider V be a value. Here volume of cube will be increasing at rate of 9 cubic centimeter per second. So what dV by dt with respect, okay, per second means with respect to time only. Okay, here dV by dt will be 9 cubic centimeter, that is centimeter cube per second. They give. Then length of edge, that is A. Okay, length, I am taking the length of edge A, so that is 10 centimeter. Now we have to take the given points. First have to find the value. Okay, what is the value of the cube? So I can consider volume of cube will be A cube. Here I am taking the side A, so volume will be A cube. So I can differentiate with respect to T, because the volume will be increasing with the centimeter per second. It means the volume will be changes with respect to time only. So I can take dV by dt, differentiate with respect to time. Here A cube, okay, the edges will be changes, so differentiation of d by dt of A cube. Again I am taking dV by dt is equals to differentiation of A cube. What is A cube? That is 3 into A square. Differentiate with respect to t only, that's why I am taking dA by dt. Okay, now I can we already given in the point dV by dt. Okay, we have dV by dt, so I can substitute the values here. It becomes 9 is equals to 3 into A square dA by dt. Okay, here 3 ones are 3 threes are. What do you mean by dA by dt? dA by dt is equals to, I can take A square on left side, it becomes divided 3 by A square. Now we have to find the surface area, change of surface area. So I can take, let surface area of cube, surface area of cube, that is 6 A 6 A square. Okay, so we want differentiate with respect to time only, differentiate with respect to time, it becomes ds by dt is equals to 6 differentiation of A square, it becomes 2A into dA by dt. We have dA by dt. We know that dA by dt. I can substitute here 6 into 2A into what is dA by dt? 3 divided by A square. So I can take A get cancelled. We have we have 6 into 2, 12, 12 threes are 36 ds by dt is equals to 36 divided by 8. So they given edges length. Okay, what is the value of A? ds by dt, edge length will be 10 centimeter. So I can substitute here 36 divided by 10. It becomes 3.6 surface area centimeter square per second. This is the result of the given problem. That is 36 3.6 centimeter square per second. Okay, let's move on the next one problem. Example number 3. A stone is dropped into quiet lake and waves moves in a circle. So have to understand the concept. The quiet lakes waves are moves in a circle. It means we have here I can drop a stone here. So the waves are moving like here. Okay, the stone is here. They moves on like here. The waves are sorry. These look like a something. Okay, just imagine circle. Okay, just imagine I can put a stone here. The waves are moving here. Okay, it form a circle at a speed of 4 centimeter per second. 4 centimeter per second at that instant when the radius of circular wave is 10 centimeter. How fast is enclosed area? Here we have to find the rate of change of area. Okay, we have to find the rate of change of area. First, whatever we have taken the given points. Given a stone is dropped into quiet lake and waves moves in a circle at speed. Okay, 4 centimeter per second. Here from this one, they move outward at 4 centimeter per second. Okay, here we have to find the area. Okay, so let A be a area. Let A be a area. Then area of circle. Okay, area of circle will be pi r square. Then we have, and what is the radius? Radius will be r. Okay, radius of the circular wave is 10 centimeter. Now here the speed of the circle per second. So it means the area will be changes. Okay, here area will be changes. Therefore, the rate of change of area. The rate of change of area is dA by dt. So what is the area? Pi r square. I can differentiate with respect to t. So I can take d by dt of what is the area? Pi r square. Now I can differentiate here. That is pi will be constant. Differentiation of r square with respect to t only. That is 2r into dr by dt. It is 2 pi r dA by dt. Here, the rate speed will be circle at speed of 4 centimeter per second. It means the rate of change of radius only. Rate of changes. The radius will be changes here. That's why dr by dt is equals to 4 centimeter per second. I can substitute here, that is 4. So what is the radius here? 4 into 2, 8 by r centimeter per second. But we want rate of change of area at radius is 10 centimeter. Great. Therefore, dA by dt is equals to at r is equals to 10. So 8 pi into, in place of r we have to substitute 10. Therefore 8 into 10, 80 by centimeter per second. Here area will be centimeter square. Okay, have to mention the units. Now let's move on the example number 4. Here the length of x of a rectangle is decreasing. Here there is a one rectangle. Okay, I am roughly taking the rectangle, that is it is length and breadth. Length and breadth. I can take length as x and breadth as a they given y. Okay, the length x of rectangle is decreasing at the rate of 3 centimeter per minute. Okay, so I can take the given point here. Let given. Okay, consider x be a length and y be a breadth. Y be a breadth only. Okay, here the length of rectangle decreases. It means the rate of change of length with respect to time only, because they given per minute. Decreasing means it is of minus. Okay, that is minus 3 centimeter per minute. Similarly, and the width or breadth of y increasing. Okay, it means dy by dt will be increasing at rate of 2 centimeter per minute only. Now, at x is equals to 10 and y is equals to 6 centimeter. Now we have to find the rate of change of perimeter. Okay, so I can take section of these two. First one, we have to find the perimeter. Perimeter of the circle will, perimeter of the rectangle. What is the perimeter? There is a one length x, here y. Perimeter means the whole surrounding. X plus x, 2x plus 2y. That is 2x plus 2y. We want a rate of change of perimeter. Therefore, I can differentiate with respect to time only. That is dp by dt is equals to 2 becomes constant differentiation of x, dx by dt plus 2 constant again dy by dt. We already know the given points dx by dt and dy by dt. Substitute here 2 into dx by dt minus 3 plus 2 into 2. Now 2 3s are minus 6 plus 2 2s are 4. Therefore, minus 2 centimeter per minute. So I can, the perimeter of the rectangle will be decreases at minus 2 centimeter per minute. Okay, the perimeter of the rectangular is decreases minus 2 centimeter per minute. Now I can take the second one using, that is, we have to find the area of rectangle. What is the area of rectangle? Length into breadth is x into y. So I can differentiate with respect to x only. Now dA by here differentiate with respect to time, that is t, dA by dt. Now I can take x is a constant, differentiate second function dy by dt plus y constant and differentiate dx by dt. Now I have to substitute here. What is the value of x? X is 10 and dy by dt, that is 2, plus y will be 6, dx by dt will be minus 3. Therefore 10 2 is 20, 6 3 is 18, 20 minus 80, 2 centimeter per minute. The area of the rectangle will be increases 2 centimeter per minute. Here the area will be centimeter square. The unit will be centimeter per square. Now we can move on the next one problem, that is exercise. Okay. Here they simply, first one question, find the rate of change of area of circle with respect to its radius. Okay. Here you have to find the area of circle with respect to radius only. Okay. First I can take area. Let's consider area, that is area of circle, that is pi r square. So first condition, I have to find the area, rate of change of area with respect to radius. So dA by dr is equals to, in place of A we have to find the formula of area, pi r square. So I can take dA by dr. Phi will be constant, differentiation of r square with respect to r. So pi into r square, that is 2r only. dA by dr is equals to 2 pi r. Here they given radius. First condition, when A is equals to r is equals to 3 centimeter, the radius will be given at 3 centimeter. Therefore dA by dr at r is equals to 3 centimeter. So here substitute 2 pi r only, that is 2 pi, what is the r? 3. The radius of the circle, area, the rate of change of circle will be 6 pi centimeter square per radius. So centimeter square only with respect to radius. So 6 pi centimeter. Similarly, when D at radius will be 4 centimeter, so dA by dr at r is equals to 4 centimeter. Therefore 2 pi R is equals to 2 by, what is the radius? 4. So I can multiply 2 into 4, 8 by centimeter square. Okay, let's move on the exercise problem number 2. Here, the radius of, the volume of cube is increasing at the rate of 8 centimeter cube per second. How fast its surface area will be increasing? With the length edge is 12 centimeter. So, have to find the surface area, rate of change of surface area. Okay, first have to take the given values. I can take, let's V be a volume of cube. So what is the value? What is the volume of cube? That is a cube. Here A B A, you can take the cube. We already know that the edges. Okay, here A B the edges of cube. Now I can differentiate value. Here we want surface area, the rate of change of surface area. So then I can take surface area only. S be the surface area of cube. Okay, I have to find the surface area only, that is ds by dt with respect to the surface area increasing when the length of edge is 12 centimeter. So it is changes with time only. Ds by dt at, what is the edge? A is equals to 12 centimeter. I have to find this only. Before finding this, we want value. They given the rate of change of value dv by dt is equals to 8 centimeter cube per second. Now I can consider value. Value here, that value of cube will be v is equals to a cube. We can differentiate with respect to t only. Okay, because they given with respect to second. So dv by dt is equals to d by dt up. In place of v, we have substitute eq. Now dv by dt, I can differentiate eq with respect to t. T will be the varies. So differentiation of eq, 3a square into dA by dt. I can substitute dv by dt, that is h. 8 3a square dA by dt. We want dA by dt, that's why taking 3a square on left side, it becomes divided 8 divided by 3a. So next we want the surface area. Already we know that the surface area formula. Okay, surface area, that is 6a square only. Surface area, the rate of change of surface area will be ds by dt is equals to d by dt of 6a square. So I can differentiate ds by dt, differentiate with respect to t only, that is 6 into 2, 12 in dA by dt. I can substitute here ds by dt at a is equals to 12. Therefore, 12 into a divided, what is the dA by dt? That is a divided by 3 a square. Here a get cancelled. We have 12 into 8 divided by 3 into I can I can substitute a value 1 into 8 divided by 3 into 1. 12 get cancelled. That is 8 by 3 surface area, that is centimeter square per second. Okay, here this is the result of the given problem. Now let's move on the next one problem, that is exercise number 3. The radius of circle is increasing uniformly at rate of 3 centimeter per second. Here the radius of circle. First let us take these given points. Let's consider the area of circle. Okay, here rate at the radius of circle is increasing uniformly at the rate of 3 centimeter per second. Find the rate at which the area of circle is increasing when the radius is 10 centimeter. Here the area will be increases. So we have to find that only. Let us consider the area of circle. Okay, area of circle will be A is equals to pi r square. Here the radius of circle increases. That is, a radius of circle is increasing dr by dt. Here radius will be changing. That's why I am taking d by dt. Okay, they given only, that is 3 centimeter per second. 3 centimeter per second, and have to find the area of circle at dA by dt at what is the radius? R is equals to 10. So we want differentiation, that is area will be area is equals to pi r square. Now differentiate with respect to time only. Differentiate with respect to time, that is dA by dt is equals to pi into d by dt, because pi b will be constant, r square. Now differentiation of r square will be 2r into dr by dt. We want dA by dt at r is equals to 10, that is radius is equals to 10. So we have 2 pi r. What is the dr by dt? What is the value? That is 3. Now I can substitute 10 only. 6 into 2, 3 into 2, 6 pi. What is the value of radius? R, that is 10. 6 into 10, 65 centimeter square per second. Okay, now let's move on the next one problem. Okay, here an edge of the variable cube is increasing at the rate of 3 centimeter per second. How fast its volume of cube is increasing when the edge is 10 centimeter long? So first have to consider the cube. Okay, then what is that? What are the given points? Here an edge of variable cube. We already know that the diagram of cube. Okay, here there is a cube. Let V be the volume of cube. So what is the volume of cube? V is equals to A cube. Here A be the edges. Here A be a edges. Okay. Now, the edges of variable of cube is increasing. The edges will be increasing. So d by dt of, okay, the edges will be vary. The rate of change of edges with respect to time only. So dA by dt is equals to 3 centimeter per second. They given this much only. So we have to find the rate of change of value. Let value V is equals to A cube. So I can differentiate with respect to T. So dV by dt is equals to differentiate with respect to T. So the differentiation of A cube will be 3A square dA by dt. We can substitute 3A square into what is the dA by dt? That is 3. We want rate of change of value at edge length. A is equals to 10 centimeter. So 3 into 3, 9 A square. So I can substitute A value here. 9 into 10 square. It becomes 9 into 100. That is 900 centimeter cube per. So this is the result of the given problem. Then question number 5. A stone is dropped into a quiet lake and waves moves in a circle at the speed of 5 centimeter per second. At the instant when the radius of circular wave is 8 centimeter, how fast is enclosed area? So first they given circle. Okay. Here I can take a stone. So this is the wave around the stone. Okay. The radius will be changes. Okay. First have to find the area. I can take, let A be the area of circle. A be the area of circle, that is A is equals to pi r square. Then a stone is dropped into quiet lake and waves moves in a circles at the speed. So the radius will be changes here. So I can take dr by dt. Radius will be r. Then the radius will be changes 5 centimeter per second. And we have to find the area, rate of change of area. That is, area will be A into pi r square. So I can differentiate with respect to T. That is dA by dt. The rate of change of area y becomes constant. Differentiation of r square will be 2r. With respect to T only, that's why I'm taking dr by dt. Now 2 pi r. What is the value of dr by dt? That is 5. We want the rate of change of area at the wave. Okay, increasing the radius of wave will be r is equals to 8 centimeter. So 2 into pi into h into 5. So I can calculate 8 5 is 40, 42 is 80 pi centimeter square per second. This is the result of the rate of change of area. Okay. Now let's move on the next one problem. That is, the radius of circle is increasing at the rate of 0.7 centimeter. What is the rate of its circumference? Okay, here first there is a circle. Roughly, I am taking the circle. There is a point, origin, here, a radius. From this point to the whole covering points are called circumference. Okay, circumference. The radius or circumference of the circle will be 2 pi r. Now, here, let's consider the radius of circle will be r, circle r, and circumference. Circumference will be 2 pi r. Here the rate of changing the increasing means changes. So the rate of change of radius with respect to t dr by dt is equals to 0.7 centimeter per second. We have to find the circumference. So circumference of the circle. Circumference of circle will be c is equals to 2 pi r. The rate of change of circumference dc by dt is equals to 2 pi. Differentiation of r will be dr by dt. Have to substitute the values. The circumference dc by dt, the rate of change of circumference at, okay, increasing, that much we have to check here. There is no points they given. There is no points they given. So simply I can calculate 2 into pi. I have to change this. That is 0.7. So calculate 2 into pi, 0.7. That is 0.7 into 2, 1.4 centimeter per second. This is the result of the given problem. Now, let's move on the next question. That is, here the next question will be very important for 5 marks. Most of the time, the question may be asked for your exam. Okay, so have to focus on it. They given a rectangle. Here there is a rectangle. Okay, the length of rectangle, it will be x, and width of the rectangle y. Here the length of rectangle is decreasing, so the length will be changes. Dx by dt is equals to how much? 5. That's why I'm taking minus, decreasing, that's why I'm taking minus centimeter per minute. And the rate of change of the width y will be increasing, that is dy by dt is equals to 4 centimeter per minute. Okay, I will take the given points. Let us consider the rectangle. Here, the length will be decreases, that is dx by dt is equals to minus 5 centimeter per minute, and dy by dt, the width will be changes 4 centimeter per second at x is equals to 8 centimeter and x is equals to 8 centimeter and y is equals to 6 centimeter. Now, first I have to find the perimeter. Similarly, I can take the two parts. First part, perimeter of the rectangle. Already we know that the perimeter of rectangle will be 2x plus 2y. Now, the rate of change of differentiation with respect to time only, that is dt by dt is equals to 2 into differentiation dx by dt plus 2 into dy by dt. I can substitute here 2 into what is the dx by dt? Minus 5 plus 2 into here 4. That is 2 5s are minus 10 plus 8. The result will be minus 2 centimeter per minute. The perimeter of the rectangle will be degrees as minus 2 centimeter per second. Similarly, the second one result, what is that? The area of rectangle. Here, area of rectangle will be length into breadth. So we can differentiate with respect to time. dA by dt. Here x and y are two variables. I can take separately. First function I am taking constant and differentiating second function dy by dt plus taking second function constant, first function differentiation. Now substitute the values here. X 8. What is the dy by dx? Sorry, dy by dt 4 plus y, it becomes 6 and dx by dt will be minus 5. Now substitute 8 4s are 32 minus 6 5s are 30. 2 centimeter per minute. The area of the rectangle will be changes at 2 centimeter per minute. This is the solution of the given problem. Here, the next one problem is question number 8. A balloon which always remains spherical on inflation. So they given spherical. Okay, they given spherical shape. Okay, here this is the balloon. I can take. Now let us consider the what is that? Spherical on inflation is being inflated by pumping 900 cubic centimeters of gas per second. Find the rate of change which radius of the balloon increasing. Balloon is its spherical shape. Spherical shape means we have to take the sphere. Okay. Here, first I can take the balloon is spherical. Okay. Here, balloon spherical. Okay. Balloon is spherical shape. So, RBV, radius of spherical balloon. Okay. Then we have to find the rate of change of radius of the balloon. Find the rate of which the radius of balloon increases when radius is 15 centimeter. So have to find the rate of change of radius, that is dr by dt at R is equals to 50 centimeter. We have to calculate this one. So first I can take the volume of sphere. Okay. Here sphere. Spherical means it's a purely sphere. Okay. Now V be the value. V be the volume of sphere. So the volume of is changes with respect to time dV by dt. What is the volume of the sphere? That is 4 by 3. Volume of the sphere will be 4 by 3 pi r cube. Okay, here pi 4 by 3 pi will be constant. I will take it outside. 4 by 3 pi and again differentiate with respect to r cube. What is the dV by dt? The changes. Okay, here they given 900 cubic. So the value will be changes. dV by dt will be 900 cubic centimeter per second. So I can substitute 900 here. That is 900 is equals to 4 by 3 pi. Differentiation of r cube, it becomes 3r square divided by, here differentiation 3r square only. Now I can take dr by dt. We want dr by dt. dr by dt. That's why I'm taking all the values on left side. It becomes 900 into 3 divided by 4 pi into 1 divided by 3r square. Okay. First, the 3 get cancelled. dr by dt at 15 centimeter. dr by dt at r is equals to 15 centimeter. So I can take here 900 into 4 pi 1 divided by, what is the r square? So I can write 15 into 50. So I will take the calculation here. 15 ones are 15. 15 6 are 90. It becomes 0. Again 15 ones are 50. 4s are 4 get cancelled. We have 1 by 5 only. Therefore, the rate of change of radius at r is equals to 15 centimeter is 1 by 5 centimeter per second. This is the result of the given problem. Okay, let's move on the next one problem. That is question number 9. This way homework for you all. This is also similar to that of the 8th question. I have to take the spherical sphere only. Here have to find the rate of change at which the volume increases. That is, we have to find the dV by dt. Okay, rate of change volume is increasing with radius. So here in place of dt with respect to radius only. That's why dr, dV by dr. Okay, so have to calculate and comment result on this problem. comment box. I have to comment the result in comment box only. Okay, now let's move on the 10th one problem. This is very much important. Most of the time will be asked for examination. Okay, the ladder 5 centimeter long is leaning against a wall. Okay, the ladder 5 centimeter long is lining against a wall. The bottom of the ladder is pulled along the ground away from the wall at the rate of 2 centimeter per second. How fast its height on the wall decreasing when the foot of the ladder is 4 centimeter away from the wall. So have to take the first. Here I can simply draw a diagram. This is the wall of the given. Okay, this is the wall. I can take the ladder here. Imagine we can take the ladder. What is the length of the ladder? Here 5 meter. Okay, here 5 meter. Now the bottom of the ladder. Okay, 5 meter. The bottom of the ladder is pulled along the ground. It means along the ground away from the wall at the rate. I will take the bottom as a y and height of the wall it becomes x. The rate of change of the bottom of the ladder will be changes. That's why I'm taking dy by dt is equals to 2 centimeter per second. And how fast its height decreasing? Okay, when the foot of ladder is 4 centimeter. Here, the foot of the ladder. Okay, the foot of the ladder will be 4 centimeter. This is the foot, 4 centimeter. That is y is 4 centimeter. Now, I have to find the dx by dt. I have to find the dx by dt. I can take here let length of ladder is 5 meter. The rate of change of dy by dt is equals to 2 centimeter per second. I have to find the dx by dt, and we know that length of the foot of the ladder will be 4 centimeter. Have to find x also. Okay, now here have to check the diagram once. Here the diagram represent the Pythagorean theorem. Okay, so I can using the Pythagorean using the Pythagoras rule. I can use the Pythagoras rule. So what is the dy by dt? We have to find the x. So what is the length, height of the wall we want? By using the Pythagorean formula, I can write x square plus y square is equals to 5 square. We know that the formula, the length of two sides, the sum of square of two sides is always equals to the third side of the hypotenuse. Okay. Here, x square plus y square is equals to 5 square. We want x square, so I can take what is the value of y? That is 4 centimeter. 25. I can take 4 centimeter directly. That is 16. X square is equals to 9 only. That's why x is equals to 9. The length of the height will be 3. Now, again, I can differentiate this one, the Pythagoreans. X square plus y square is equals to 5 square. I can differentiate with respect to time. Okay, here differentiation of x square, that is 2x dx by dt plus 2y dy by dt. Differentiation of constant will be 0. Now, we know that the x value, so I can substitute directly. 2 into, what is the value of x? 3. We want dx by dt, so I can take here dx by dt will plus 2 into y. What is the value of y? That is length 4 into dy by dt. dy by dt will be 2. Here it is decreasing, so I can take minus, here minus 2. 2 3 is 6 dx by dt plus here 0. 2 into 4 8. 8 is 16 minus 16 is equals to 0. dx by dt is equals to, taking minus 16 on right side, it becomes plus 16. Here 6 only. That is dx by dt is equals to 16 by 6. The value I can take 2 3s 2 8s. That is dx by dt will be 8 by 3 centimeter per second. Here the height of the ladder will be decreases. Height is decreasing, therefore the value becomes negative. dx by dt is equals to minus 8 divided by 3 centimeter per second. This is the result of the ladder. The rate of change of decreasing the height of the ladder will be minus 8 by 3 centimeter per second. Now let's move on the question number 10. A particle moves along the curve 6y is equals to x cube plus 2. Find the points on the curve at which the y coordinate is changing 8 times as fast as the x coordinate. Okay, here I have to check the curve. Let's consider the curve. Y 6y is equals to x cube plus 2. Okay, we have to find the y coordinate. Okay, here y coordinate, the curve y coordinate is changing 8 times fast as x coordinate. That is dy by dt is equals to 8 times of dx by dt. Now I have to find the curve, change of the curve. Let 6y is equals to x cube plus 2. I have to differentiate with respect t. So 6 into dy by dt is equals to differentiation of x cube. So I can take here, it is x cube plus 2. It is 6 dy by dt is equals to 3x square dx by dt. Differentiation of 2 will be constant. So we want dy by dt. Okay. Find the points on the curve at which one. So we have to find the dy by dt. That's why taking 6 on right side, it becomes divided by 3x square divided by 6 into dx by dt. Okay. Now, have to substitute here the values dy by dt. 3 ones are 3 twos are x square by 2. I can take dx by dt is equals to, what is that? Replace dx by dt. Okay. Here I can replace dy by dt is equals to, what is that? 8 into dx by dt. Here dx by dt and dy by dt will be 8 into dx by dt is equals to x square divided by 2 into dx by dt. This dx by dt will be get cancelled. We can take x square is equals to, taking 2 on this one, it becomes multiplication. X square is equals to 16. X is equals to plus or minus 4. Okay. When y, okay, here the values of curve 6y is equals to x cube plus 2. When x is equals to 4 and x is equals to minus 4. I have to check the curve. Okay. While substituting the values, 6y is equals to x cube. What is the x cube? That is, in place of x4, 64 plus 2, that is 66. 6y is equals to 66. 6 11s are. Therefore, the given curve y is equals to 11. Therefore, the points here, the points, the curve, the curve at, what is the x? 4, 11. Here also I am taking, that is 6y is equals to minus 14. That is minus 64 plus 2. Y is 6y is equals to minus 64 plus 2 minus 62. So y is equals to minus 62 divided by 6. Then the curve. Okay, the curve, given curve at minus 4 comma 62 divided by 6. This is the result of the given one problem. So let's move on the next one problem. You can solve here. So this is also related to the sphere. Have to homework for you all. Now next, move on the problem. A balloon which always remains spherical has a variable diameter 3 by 2, 2x plus 1, and find the rate of change of its value respect to x. Here I can take, let's take the sphere of volume. What is the volume of sphere? That is 4 by 3 pi r cube. The rate of change, the volume will be changes with respect to x. So I can take here in place of radius, it can be expressed in terms of x. Okay. Now, sorry, I can just confused here. Here will be same only. The text here will be r cube only. The value will be changes with respect to x. So dv by dx is equals to d by dx of what is the value? That is 4 by 3 by r cube. So I can differentiate with respect to x. The dv by dx is equals to 4 by 3 into 5 will be constant. Again differentiation of r cube. So I can take 4 by 3 by differentiation of r cube 3 r square dr by dt. Okay. Here they given the diameter. Okay. They given diameter. What is the diameter? We know that diameter of the circle is always 2 into r, 2 times of radius. So the diameter will be 3 by 2, 2x plus 1. Okay, here is equals to diameter can be expressed as 2r. So the radius will be taking 2 on this one. It becomes 3 by 4, 2x plus 1. Then differentiate with respect to x. So dr by dx is equals to 3 by 4 will be constant. I can take differentiation with respect to 2x plus 1. It becomes 3 by 4. It becomes 3 by 4. Differentiation of 2x will be 2, 1 will be constant. Therefore, 2 ones are 2 twos are, it becomes 3 by 6. So I can substitute here dv by dx is equals to 4 by 3 into 5 into 3 r square. What is the dr by dt? That is 3 by 2. Here, 2. Here, this is 3 by 2. Now, I can substitute here. That is dv by dx is equals to 4 by 3. This 3 get cancelled. Okay. 2 ones are 2, 2 get cancelled. 2 twos are. Now 2 pi r square. They given 2 pi r square. I can substitute the value of r. 2 pi. What is the r square? It becomes 3 by 4 into 2x plus 1 whole square. This is the result of the given. That is the rate of change of value with respect to x. Okay, the rate of change of value with respect to x. Okay, this is the result. Now let's move on the next one problem. That is question number 14. The sand is pouring from the pipe at the rate of 12 centimeter cube per second. The falling sand forms a cone on the ground in such a way that the height of the cone is always one-sixth of the radius of base. How fast its height of the sand cone increasing when the height is 4 centimeter. So first have to consider the cone. Okay, consider the sand forms a cone. Okay, here the sand is pouring from a pipe at the rate of change of 12 centimeter cube per second. Okay, here it is. Okay, the falling sand forms a cone on the ground such a way that the height of cone always, here they given height h is equals to one-sixth of its radius of base. Here we know that the cone shape. This is the radius and this is the height from the base. Okay, now the rate of change of cone. Here height will be one-sixth of radius. That is 1/6 of radius. Now this one 6h is equals to radius. Okay. Then the height of the cone always sixth. How fast the height of the sand is increasing? We have to find the height dh by dt at 4 centimeter. At h is equals to 4 centimeter. We have to calculate. Before going to that, here there is a one point. The pouring, its mean volume will be increases. Volume of cone. It is volume of cone. What is the volume of the cone? That is 1/3 pi r square h. Okay, volume of the cone will be 1/3 pi r square h. The volume will be changes. The rate of change of volume with respect to t. So I can take 1/3 pi pi r square as a constant. So take the height will be changes. So I can differentiate d by dt h of h. Okay. Here I can take the radius. Okay. Radius also we have. Okay. I can substitute the radius by using this relation. dv by dt is equals to 1/3 into pi. What is the radius? 6h. It is 6h square into dh by dt. What is the dv by dt? That is, we know that the rate of change of volume they given. Okay, that is dv by dt. They already given 12 centimeter cube per second. I can substitute here 12 is equals to 1/3 into 5. What is 6 square? That is 36 into h square dh by dt. 12 ones are 12, 3s are 3 ones are 3. Therefore, we want the rate of change of height, that is dh by dt is equals to, I'm taking all the values here, that is 1 divided by pi into h square. We want the rate of change of height only. Okay, I can substitute here. That is dh by dt at height is equals to 4 centimeter. Now 1 divided by pi into what is the h? 4 square. Therefore 1 by pi into 16 centimeter per second. Here value meaning height. Okay, that is centimeter per second only. The rate of change of height at 4 centimeter is 1 divided by 16 by centimeter per second. At h is equals to 4 centimeter only. This is the result of the given problem. Okay. Let's move on the next one problem. Okay. Up to this much, all the problems I will solve. So have to solve the homework problem also. Your comments will help to improve my next class better than this. So have to share, subscribe and like my channel. Thank